All right, so today we're going to take a look at the second part of the first module. And just as a review, the last time we met, we constructed a frequency distribution where we had a raw set of data. We took that raw set of data, organized it into classes, and I believe we found the frequency, the midpoint, and some other things, right? Today we're going to continue on, and we're going to talk about a 5-number summary. And a 5-number summary is a way to just summarize a data set. Now, we're going to see information displayed in two ways. One way is just a list of numbers, right, where you have however many numbers is just a list. We'll also be taking a look at numbers that are within a distribution, such as a frequency distribution. So we're going to calculate the 5-number summary or statistics for both sets of numbers and also distributions. Okay, so here's a 5-number summary, and it's just the 5-number summary consists of finding the minimum or the smallest value of a data set or list of numbers. Also, the maximum value. Okay, so this should actually say minimum and maximum. So you should be able to find the smallest number in the data set, the largest number in the data set, and then we also have quartiles. There's the first quartile, and as we progress further along in the course, that first quartile is known as the 25th percentile. Once we talk about percentiles, there is a median or a second quartile. The median, if you have a list of numbers, the median would be the number that's in the exact middle. Right? So you have to put all the numbers in order. The median, which is the second quartile, or the 50th percentile, once we talk about percentiles, is that middle number or the median. And as I'm kind of looking at the median, there's something called an average, right, where you take all the numbers in the data set, you add them up, you divide by the number of numbers. And there's also something called the median. If you are looking for a job, if you're looking in the occupational outlook handbook or whatever, looking for a job, you'll notice that it normally will give you the salaries median for the job, right? It'll say the median salary for a nurse is, let's say, $50,000. This is why they don't necessarily give you the average. They'll give you the median. It's because the average takes into account large and small values. Right? For example, let's just say we have 3 nurses. One nurse just starts, let's say she makes about $30,000 a year. We have another nurse who has, let's say, been there for 10 years, right? She makes like $100,000. If you were to like average those two numbers together, you would get the middle salary for both of those, right? But if you're just starting out in the nursing field, I doubt very seriously if you're going to get paid more than that lower salary range. So that's just one of the reasons why if you're looking at salaries, they always will give you like the median salary versus the average salary, okay? Because the average takes into account extreme high and extreme low scores for salaries, whereas the median just puts everything in order and just finds the middle value. We're also going to take a look at a box and a whisker plot. And a box and a whisker plot is just a physical representation of this 5-number summary. right? In a box and Whittaker diagram, you can actually pull out the minimum value, the maximum value, quartile 1, the median, which is quartile 2, and quartile 3. All right, so we're going to take a look at some examples that deal with this 5-number summary. And on the handout, there is problem number 1. And this is from Module 1, Part 2 handout. So just to show where I'm pulling this from. Okay. If you're in our course over in the lecture notes section, okay, you'll see the PowerPoints, which I'm lecturing from, and you also see the handouts. All right, so I'm actually pulling up this handout number 2, and this is the first problem on the handout. All right, so it says based on, and this is called a box plot. So let me just explain what a box plot is. It's a box plot. Sometimes it may be referenced to as a box and whisker plot. So it consists of a main rectangular body. So notice how I have, these are called the whiskers, or the minimum value and the smallest value. They're not actually considered to be within the Q1 through Q3 range. Right. If we look at the box, notice that this box has 3 vertical lines. This first vertical line, it serves as, I forgot I can write on this. All right, so this would be our I don't know why this pen changes up. All right, this would be our minimum value, this very first vertical bar. The very last vertical bar, this would be our maximum value. And if we take a look at the actual box itself, the beginning of the box, this is Q1. Right, that will be located at that first vertical line of our box. Now, even though this is not exactly in the middle, but it's in the middle of the Q1 and Q3, this is actually the median, which is Q3. And then the last vertical line for our box, well, excuse me, that's the median, or Q2. And then we have Q3. All right. Try to blow this up a little bit. So I'm just going to pull out these values from this box plot. So what is our minimum value? Right, that's going to be 16. Q1 is going to be 17. The median, or Q3, excuse me, the median, or Q2, is 26. Q3 is 31, and the maximum is 34. Right. All right, so here is an example of a box plot, and from that box plot we can pull out our 5-number summary. Now, we won't actually construct any box plots, okay, but you will have to read one. All right, any questions about the box plot? All right, going back to the bless you. All right, to the notes, let's take a look at some definitions. And we have the mean. The mean is also called the average. So they use those 2 terms interchangeably. The mean is found by adding up the numbers and dividing by the number of numbers. There is the median, and the median is the number that's in the center of your data set. The mode is the value that occurs most often. It's possible to have no mode. It's possible to have one mode. It's possible to have 2, 3. It's the number or the value that occurs the most. And we'll take a look at an example of a mode. The range of a data set is a maximum value minus the minimum value. The standard deviation is a measure of variation of values about the mean. And then we have the variance. The variance is equal to the square of the standard deviation. All right. Now, as far as the mean, we've probably seen the mean before. The median, we're going to arrange the values in order to pull out the middlemost value. The mode is the number that occurs most often. We can use the calculator to find the mean and the median, but the mode is something that you would have to visually inspect. Okay? Or either put all your numbers in the list, put the list in orders and see which number or numbers appears the most. The range is the maximum value minus the minimum value. The range is not actually a calculator function. And where is my calculator? Okay. All right, just bringing my calculator up. So the range is not a calculator function. The standard deviation and the variance, they're calculator functions. Okay. Now, there are formulas to find the standard deviation and the variance. And we're not going to use these formulas at all. We're going to use the calculator functions, but I do want to show them to you. Maybe I should be a little bit more specific. Sample. And this is the formula for what the sample standard deviation looks like. And you see this funny looking summation symbol. That's sigma. That's a letter of the Greek alphabet. That just simply means to add, repeated addition. You have a square root, and then you have x sub I minus x bar, and x bar is the mean. You got to square that. This is like a tedious formula if you actually had to do this by hand. And in order to find the variance, we're going to talk about the variance. You would simply take this value and square it. All right, I'm going to go to the handout, and I'm going to skip over problem 2 momentarily, and let's take a look at problem number 3. Okay, so I'm given a data set. It's just a list of numbers, and we're asked to find the mean, the median, the mode, the range, standard deviation, and the variance. Okay. And we'll take a look at finding these things a couple ways. I'm going to call this method 1. And we're going to use the one variable statistics. One variable statistics. All right. So we're going to take this data set and put it in our calculator. So just recall, in order to put a data set into your calculator, I'm going to just turn it on and just clear everything out. I want to go into Stat. And am I recording this? Yes, I am. All right, we want to put the data into the calculator. So I hit stat. All right, I'm going to choose that first option, which is edit. And I'm going to hit enter. So I already have some data for list one. I can either hit delete and kind of delete each one at a time. All right, or I can go to the very top of the list. I can hit clear and enter. All right. So now I'm going to put in these 8 numbers. And after every number, I'm going to hit enter. 22. So now anytime we're going through these calculator steps, if you don't see what I see on my calculator, please raise your hand and stop me. All right, so we can just make sure everybody is on the same page as far as this calculator is concerned. All right, so I'll put the data into the calculator, and the second thing is we want to return to the home screen. And that's the second and mode key, right? So anytime you perform any operations, you must be on the home screen. All right, so we put the data into the calculator. Now we're back at the home screen. The next thing we're going to do is calculate the statistics. So I'm going to go into stat. I'm going to scroll over to calculate. And my very first option is one variable statistics. And I'm going to hit enter. You have to, from this point, tell the calculator which list you want to calculate the one variable statistics from. If you have, I believe if you have a TI-84, your screen may look a little different from this. Is everybody seeing this when you hit one variable statistics? Okay. So now I'm going to have to put in list one, because remember we put this data set in the list one. So if you look close at your calculator, above the number 1, there is a list 1 and it's yellow. I can recall list 1 by pressing second and 1. So you have to tell your calculator which list you want it to perform these statistics. So what did I do next? So it was stat, calculate, one variable statistics. Then I think I hit second. And choose your list. So I put in L1, but I'm going to say choose your list because later on we're going to put in like 2 lists. All right. So if I hit enter, it gives us the one variable statistics output in the calculator. All right. So is everybody kind of seeing what I'm seeing? So let me kind of explain this one variable statistic. So notice you do have this little down arrow. So that means there's some more output. So I'm going to hit this little down arrow eventually. Okay. So the first thing we see is X bar. X bar, that is the mean. That's both the sample mean and the population mean. So when you see X bar, that could be the sample mean and it's the population mean. Because sometimes they'll ask you these little weird questions about the sample mean and the population mean. But since we have, this is an actual sample, right? 8 items, this would actually be the sample mean. The very next piece of output you see, this is the summation of X. So this is the summation symbol sigma, and it just means repeated addition. So now this is not part of our 5-number summary, but it's what the calculator uses to calculate the 5-number summary. So let me just tell you what this summation of X is. If we were to take all 8 numbers in our list and add them up, it would add up to be 189. You take those 8 numbers, add them up, it adds up to be 189. That's what this summation of X is. The summation of X squared, it means that if you take all of those X values, you square them, and then you add all those squared values together, it would give you 5,259. This S of X that you see, this is the sample standard deviation. And that is 5.099. So if you're ever asked for the sample standard deviation, that is S of X. The next piece of output, this funny looking circle that is read as sigma. And that is the population. So like in the last class, we talked about parameters and statistics. And a parameter describes a population. A statistic describes a sample. So this S of X is a sample standard deviation. This sigma sub X is a population standard deviation. And that's 4.72. Okay. All right, so now N is equal to 7. One, 2, 3, 4, 5, 6, 7. Did I miss a number?
Yes, I was like,
Okay, so I'm gonna just go back. N is equal to 7. That means N is the number of items in your data set. So apparently my data set is not right because I have 7 items and I'm supposed to have 8, so I'm going to check my list. I'm going to go back into stat, edit. Okay, I think I missed 34. 29, 25, 34. So I'm going to put in 34.
Not 34.
Huh?
Not 34.
Do I?
Mm-hmm. Yeah, 34.
It's twice. Okay. So now I'm going to hit enter. So now I have a total of 8 items. So I'm going to recalculate everything. So I'm going to go back to the home screen. I'm just going to clear that out. Now I'm going to just recalculate the statistics. I'm going to hit stat, calculate, okay, one variable statistics, and I'm going to choose list 1. Right. So y'all should have stopped me. So.
I was like, maybe if I let him go, I'm going to find out where I went wrong.
Yeah, I went wrong.
No, I can be wrong sometimes. All right. So now that we have 8 numbers, all right. So let me just go back and change it. So the mean X bar is 27.875. Come on. I guess I'll round that to just 27.9. Okay, the summation for X, so now we have another number added. So if you were to add up all 8 of those numbers, you should get 223. Sigma X squared is 6,415. S of X is the sample standard deviation, and that is 5.33. The population standard deviation looks like 4. I'm just going to round that to 5. N is the number of items in your data set, so it should be 8. And now notice it has this little down arrow. So if I hit down on my output, now it's going to give me that 5-number summary. The smallest value in the data set is 20. Q1 is 23.5. The median is 28. So let's see, the mean was 27.5. The median, which is Q2, that is 28. Okay, you can't pull the mode from your calculator, right? In this 5-number summary, there is no mode. There also is no range, right? But you can actually find that range by the minimum and the maximum value. And unfortunately, there is no variance. Right? So if I keep going down, Q3 is 33. The max is 34, and that's the 5-number summary. Okay. But there's still some stuff over here I got to find. I got to find the mode. I got to find the range. And it gave us the standard deviation, which was
How did you find the mean?
the mean.
Yeah. Where is it?
Okay, if I go up, the mean was that very first output.
Yeah, because you wrote 27.5, right?
Oh, that's 27.875. Okay, so the median is 28. How could we find the range? I can subtract the 34 from the 20, so the range is what? 14. What is the mode? Well, if we take a look back at our data set, we found that 34 popped up twice, right? So 34 would be the mode. Now, as far as a mode is concerned, it's possible to have no mode, and it's possible to have more than one mode. For example, let's say if I had a 25 in this data set, the mode would then be 25 and 34, because 25 would appear twice and 34 would appear twice. That's if there was a 25 in the data set. All right, what is the standard deviation? right? That is the 5 point, let me just calculate it over. That is the 5.33, right? We're looking at the sample standard deviation.
So if you just ask for standard deviation, how do you know if it's population is central?
Well, it's going to ask you. Well, this one didn't ask, but since we have a sample of numbers, then it would be a sample standard deviation. Now, we're going to see a problem in a second. It asks for the population standard deviation. Okay, I just want to point that out earlier that these two are something totally different. This is for a sample or a statistic, and then this is for a population. That's a parameter. All right, now the variance. There is no variance in this in the one variable statistics section. All right. Over here, I'm going to put up method 2. All right. And method 2 is using list functions. So I'm going to just clear out my home screen. Right? And we already have the list of numbers in list 1 on our calculator, right? So what we did a second ago is we used the one variable statistics. I'm going to use something a little bit different this time. I'm going to use what are called list functions. On your calculator, above the stat button, you see the word list. I'm going to go into list, so that is second in stat, which is list. Well, this is to calculate the statistics. I hit second, and now I'm going to hit stat. And then these things together make a list, right? They actually are calling up this list function. I'm going to scroll. Okay, this is what you should see when you hit second and stat. Okay, I'm going to scroll over to OPS, means operations. I'm going to scroll over to math. Okay, and let's take a look at all of these functions that are in this list. We have minimum, maximum, mean, median. Sum is just sums up all the numbers in the list. Product, it'll multiply all the numbers in the list. There is a standard deviation function. And there is also a variance function. So variance is not in the one variable statistics. The variance function is actually in the list part of things. So now this is how you use it. So I want to find the variance, so I'm going to hit variance. And then you have to tell the calculator which list you want to use. So I want to use list 1, so I'm going to hit second and list 1. I'm going to close off my variance function, and the variance is 28.4. So the variance, that's equal to the standard deviation squared. I could also find the standard deviation. I can also find the variance by taking this 5.33 and I could square it. That's going to give me something close to this number. Okay, not exactly because I did round a little bit, but notice I get 28.4. So the variance is 28.4. So in order to find the variance, you have to take the standard deviation value and you have to square it. Or you could use a list function. Like I could use this list function to find the mean. I can just put in that third option. I can tell it which list I want, and it gives me that 27.875. I could find the standard deviation, and it should give me that same 5.33. Okay, so any questions on how to calculate the mean, median, mode, standard deviation, variance using the calculator? All right, so just some calculator functions there. I'm going to go back to the lecture notes, and we're going to talk about a weighted mean or a weighted average. And this is no more than how you calculate a GPA. You calculate a GPA by using what's called weighted mean or weighted average. So there's a convoluted kind of formula for this. But it says the weighted arithmetic mean is similar to the ordinary arithmetic mean, except that instead of each data point contributing equally, the final average of some data points contribute more than others. So now this is what the formula says. It says the weighted average is equal to, and this summation, that means repeated addition. So you have to take your X values, you have to take your W values, multiply them together, add them up, and then you have to divide by the sum of your W values added up. And now we're going to see an example of this. All right, but this is the formula. As we go through the example, we'll take a look at the formula. Now, this is something that is not on the slides. Okay, but this thing used to just let me slide it over. Now I got to do all kind of crazy stuff. All right, we're going to take a look at a GPA calculation. All right, so this is something I just made up. I mean, as far as the grades are concerned. All right, so this is not actually on the handouts, okay, but I will just feel like I'm not a good statistics teacher if I did not show you how to calculate a GPA. Okay. One thing I can tell you about a GPA is that the best way to improve your GPA is not to just take an easy class to get an A in it. That's like the misconception. The best way to improve and the quickest way to improve your GPA is to take a class you didn't do so well in and make a better grade. And I can actually show that mathematically. All right, so a lot of students will ask me, I'm trying to raise my GPA, I want to sign up for some easy classes. That's not really the best way to improve your GPA. Go back and retake classes and get a better grade. All right. All right, so here's a GPA calculation. So let's say here is our transcript. We had statistics, and we got an A because Mr. Cummins was teaching it, and he's about the best statistics teacher in the world, so you get an A. Biology, there was a C. Music, That was a B. English, that was a C. And let's say college skills, we got a A. All right, so let's just say these were your grades for a typical semester. All right, so we have our grades here. And then we have a credit hour. I'm going to put that in the next column. So statistics is a 3 credit hour course. Biology is a 4 credit hour course. Music is a 3 credit hour course. English is 3. And college skills is a 1 credit hour course, right? So in this particular semester, we had taken 7, 8, 9, 10, 14 credit hours. So next we have what's called a grade point. And all depending upon where you're looking at this. In some instances, they may not call it a grade point. They may call it something else, right? But this is the way I learned how to calculate a GPA. So what a grade point is we turn our letter grade into a numerical grade, right? It has some kind of value. So on the, well, I guess the 0 through 4 point scale, A carries how much weight? That's a 4, right? A C is worth, just so that we're all on the same page, we have A, B, C, D, and F. A is worth 4 points. A B is worth 3 points. A C is worth 2 points. A D is worth 1 point. And an F is worth 0 points. All right, so what I'm doing is I'm converting my letter grade into its equivalent point grade. All right. So an A is 4, a C is 2, a B is 3, a C is 2, and an A is 4, right? So next I'm going to multiply. So as far as the weighted average is concerned, this funny looking formula, you got X and W, right? This is going to be X, and this is going to be W. So my grade point is X, and my weight or my credit hour is W. So this formula says that we multiply X times W, and then we add up all of the X times W values. So I'm going to multiply X times W, and I'm going to call this the quality points. So if I multiply 4 times 3, I'm going to get what? 12. 4 times 2, so remember I'm just multiplying the credit hour times that grade equivalent numerical value. 4 times 2 is 8. 3 times 3, 9. 3 times 2, 6. And then 1 times 4 is 4. All right. So I multiplied X times W. This is the sigma thing, is I add all of these up. I have to take all of these X times W values and add them all up together. So that is 12 plus 8 plus 9 plus 6 plus 4 is 39? I believe 12, 8, 9. That's 39. The sigma sub W, we kind of did that earlier, right? So in the formula, my numerator, the summation of xi times w sub I, that's going to be the 39. The denominator is the summation of w sub I, so that's all of my credit hours, which is 14. So the GPA is equal to 39 divided by 14, which is 2.79, right? You always round your GPA to the nearest hundredth. Any question about that? I added up all of these. Okay. All right, so now with that being said, Aiken Technical College goes on this scale, but there are other institutions that use a different scale and their GPAs are higher because of this fact. So that's what I mean. And I think USC Aiken uses this scale. Instead of A, B, C, D, F, they have an A plus, they have an A, they have a B plus, they have a B, they have a C plus, they have a C. I think they may even have a D plus, a D, and then they got an F. So where this breaks down, this is a 4, this is a 3.5. This is a 3. What if I'm doing something wrong? 4.5, I know it's a 0.5 scale. Let me just look that up. And I pulled it up. Oh my goodness. Okay, here's one. A is 4, A plus is 4, A is 4, A minus is 3.7. You see how your GPA could be a whole lot higher, whereas our scale is just 4, 3, 2, 1, 0. They have 3.7, 3.3, 2.7. Okay, since I'm not a student here, you all, and I tell this to all my statistics, you all got the power. You all could change this grade and GPA thing if everybody were to come together. So I just want to bring that up because some GPAs are a little bit more inflated than others just because of the GPA calculation that they're using. All right, so that is a GPA calculation. All right. And just as we move on, the best way to raise your GPA is to retake a course and make a better grade. Okay. All right, so with that being said, we're going to move along to the example that's actually on the handout. I think I skipped over it. It was number 2. All right, so you will see one like this on the test. Unfortunately, not the GPA one. But it says in one particular month, A person has a balance of $3,240 on their credit card for 12 days. They make a purchase and carry the balance forward for the next 8 days. Then the person makes a payment and carries the balance of $2,070 for the remaining 11 days. What is their average daily balance? Okay, round it to the nearest cent. So it doesn't actually tell you to use a weighted average. It just says what is their average daily balance. But we're going to use the weighted average calculation. So in this particular instance, we have the balance carried forward. That's like our X. We also have the number of days. That's our W as far as that form is concerned. And so looking back at our problem, it says that $3,240 was in the account for 12 days. $3,290 was in the account for 8 days. And then $2,070 was in the account for 11 days. So we're basically going to do the same thing. We're going to find the summation. Well, we're going to find X times W. So we're going to multiply going across. So 3,240 times 12 is 38,880. I'm going to multiply 3,290 by 8. And that is 26,320. 20,070 times 11. 22,770. All right. So we multiplied all the balances by the number of days carried forward. Now we're going to find the summation of X times W. I'm going to add all that up. 26,320 plus. And I believe we get 87,970. Right, so that's our numerator. And now we want to find the summation of all of our days. So 12 plus 8 plus 11 should be 31. And now in order to find the daily average, that's equals to $87,970 divided by 31. So I believe that should equal to 87. All right, and you always round money to the nearest hundred, so that'll be $2,837.74. All right, so that would be the average daily balance. All right, so any questions about that weighted average or GPA calculation? All right, going back to 2000. Yeah, $2,837.74. All right, any other questions about that? All right, let's move a little bit forward, and we were moving up from a set of numbers to a frequency distribution. So from the frequency distribution, we're going to calculate some of the same things: the mean, the standard deviation. Those are going to be the main things we calculate from a frequency distribution. So what we have on the slide is just an example or another example of a frequency distribution. So just notice for this frequency distribution, we have the classes on the left, in that left column, and then on the right column, we have the frequency. On the handout, problem number 4 is that same exact frequency distribution that you see on the handout. So notice here it asks for the population mean. So keep in mind X bar, that means both population and standard deviation mean. But for the standard deviation, notice that there is a output for sample standard deviation and populations standard deviation. So you want to be careful. Here we want to use that sigma sub X value. All right, so we're going to calculate the mean and the standard deviation from this frequency distribution. The first thing we have to do is we have to find the midpoint. All right. So remember, there is a formula to find the midpoint. To find the midpoint, you simply take the lower class limit, you add that to the upper class limit, and you divide by 2. So we're going to find the midpoint for each one of these classes. All right, so 50 plus 57. So now I am hitting enter before I divide.
So you're essentially finding the average.
That's right. That's right. That's right. That's right. All right. So notice I added, I hit enter, and now I'm going to divide by 2. So that first midpoint is 53.5. So it's something we did the last time. We were calculating the midpoint for that frequency distribution. You could do that for every class, right? I'll do it for the second class. 58 plus 65 is 123. If I divide that by 2, I get 61.5. Or there's something else I can do, right? I could find my class width, which would be the lower class. If I subtract consecutive lower class limits or consecutive upper class limits, I can find my class range, and I can just keep adding that value. So what would be the class width? 8, right? Because 58 minus 50 is 8. So I could just repeatedly add 8. So like 53.5 plus 8, that's going to give me 61.5. I can add 8 again. That's going to give me 69.5. If I add 8 again, I'm going to get 77.5. If I add 8 again, I'm going to get 85.5. And if I add 8 again, 93.5.
And you can use, like the 73 minus 65 and still come up with 8 for the width.
Right, right. You can use those consecutive lower limits or consecutive upper limits. That's correct. So any questions about the midpoint? All right, so the reason why we calculate the midpoint is that we need the midpoint in order to find the mean and the standard deviation. All right, so that's the first thing we did was find the midpoint. So let me write some steps over here. The first thing. Find the mean. I'll be more specific. Find the population, mean, and population standard deviation. The first thing we did was find the midpoint. The second thing I have to do is put the midpoint in the calculator as list 1 and the frequency as list 2 into the calculator. So we had a frequency distribution, we found the midpoint, and now I'm going to use that midpoint. I'm going to put that into list 1. I'm going to put the frequencies or the counts into list 2. All right. So I'm at the home screen. I just cleared everything away. Remember, in order to put data into your list, I want to hit Stat, and I want to choose Edit. All right. I'm going to go to the very top of list 1. I'm going to hit Clear and Enter. Clear that out. Okay, now is everyone seeing specifically list 1 and list 2? All right. So for list 1, remember we're going to put in the midpoint. So that's 53. Okay. 69.5, 77.5. Yeah, 53.5, 61.5, 69.5, 77.5, 85.5, and 93.5. And we're going to put in the list 2 as the frequencies. So I have the midpoints as list 1 and the frequencies as list 2. Okay. Now from this point, we want to return to the home screen. So that's second in mode. Right, so second in mode, I'm at the home screen. The next thing we're going to do is calculate the statistics. So I want to use that one variable statistic. So I want to use stat. I'm going to scroll over to calculate. I want one variable statistics. I want to hit enter. Now, if you have a TI-84, your calculator may look a little bit different. I believe if you have a TI-84, can I take a look at one real quick? You got list and frequency list. For list, you want to put in L1. So if you have a TI-84 or better, you have something that says list, you want to put in L1. And for frequency list, you want to put in L2. But for this older model calculator, I got to click L1. I have to put in a comma and L2. So that's the difference. For the 83 and below, for one variable statistics, you must put in L1, because remember L1 was our midpoint, comma L2, and L2 was the frequency. If you have an 84 or higher, list is L1, frequency is L2, I'm going to hit enter. What is the population mean? It should be 67.6. They say round the 2 decimal places. So in order to round the 2 decimal places, I'm going to look to 2 places after the decimal, which is the 9, right? If I look 1 number to the right, since that number is 5 or greater, I have to round my 9 up, which rounds is 5 up. So I should have 67.6. But just notice, from what I alluded to earlier, the population mean and the sample mean, that's the same X bar. But the standard deviation is different. So I want the population standard deviation. So I want to use this sigma value. So the population standard deviation should be what? 12.24. And that's where you have to be careful on which standard deviation value they want. If they want the population, you want to use that sigma sub x value. If they want the sample, then you use S sub x.